Hey everybody, it's Mrs. Hale here. I just wanted to take a minute and go over the mirrors assignment with you that you are working on in Module 8. In this video, we are going to talk about how to solve curved mirror problems and determine whether the image is virtual or real and whether it's upright or inverted. And then we're going to look at how to draw the ray diagrams for these different curved mirrors that you guys are working with. All right, in part one of this assignment, you are asked to find the distance to the image in the curved mirror problems, and then you're going to state again whether the image is virtual or real or whether it's upright or inverted. So how do we figure that out? How do we know whether or not it is virtual or real or whether it's upright and inverted? What we have to do is we have to do a calculation to find the magnification of the image. Um, if once we do that, if the magnification is positive, then we know that the image is upright and virtual. But if the magnification is negative, then we know that the image is real and inverted. And so that's our goal. So in order to do that, we're going to actually use two different equations. To find the magnification itself, we need to know the distance of the image from the mirror, and then we also need to know the distance of the object from the mirror. And so that is represented with SI, that is the image distance, and that has to be in the magnification equation, it is negative SI, so negative the image distance divided by the object distance, SO. But sometimes we aren't given all of that information, so we might have to do a calculation to actually find the missing piece of information. So then you will be actually using this other equation where 1 over the focal point is equal to 1 over the object distance or plus 1 over the image distance. So those are the two equations that we're going to be using to actually solve these problems. So let's look at the first problem, the first example problem. So if it asks us to find the distance to the image in the curved mirror and state whether the image is virtual or real or whether it's upright and inverted. So the first problem we're given, we have an object that is 1.0 centimeters from the convex mirror. So that's our first piece of information. The object itself distance is 1.0 centimeters. So we write that over here, SO is equal to 1.0 centimeters. And we know the focal length, which is 4 centimeters. And since it's a convex mirror, it's going to be negative 4 centimeters away from the mirror. So we're going to go ahead and put down negative 4.0 there. And then we're going to use that equation to find SI, because that's the other piece that we need to know in order to determine the magnification. So we use this equation that 1 over the focal point is equal to 1 over the object distance plus 1 over the image distance. Again, we know SO, we know F, so we can plug in and we solve for SI and we end up with negative 0.80 centimeters is the distance that the image is from the mirror. And so then again, in order to determine whether or not it's virtual or upright, we just want to know what its magnification is. Again, if it's positive, it's going to be virtual and upright. If it's a negative magnification, it's going to be real and inverted. So we put in the image distance and negative the image distance and divide it by the object distance. And remember that we found that the image distance was actually negative 0.80. So when we plug that in there with the negative sign, it actually becomes positive. And then we divide that by the object distance, which gives us 0.8. So this is positive. So we know that our image is virtual and upright. So that's the first piece of part of the problem that we have to do. For the second part of the problem, you're asked to actually choose 3 of these different problems, and you're going to draw these ray diagrams for them. So we know some different pieces of information from our problem that will help us in drawing the ray diagram. We know the object distance, we know the image distance, and we know the focal point, and we know the magnification. So we know the difference between the size of the image and the size of the object. And so that's what we're going to draw when we draw these ray diagrams. So it matters what type of mirror that you're working with. If it's a concave mirror, the way that you would actually draw these is you're going to, first of all, you're going to use a solid arrow to represent the image, and then you're going to use a gray arrow to represent a dotted line, a dotted arrow to represent the image. And so in this case, we actually have where the image and the object and the image are on opposite sides of the mirrors. So this is an example of a virtual and upright image. Whereas on this other one, we actually have an image that is on the same side of the mirror, which is an example of a real and inverted image. And again, this line here is going to be our principal axis. And then we are going to draw, we're going to draw each of these different objects the certain distance away from the principal axis that we got from our calculations. And then this is the focal point over here. And then we're going to be drawing these rays. So if we're drawing the rays for the concave mirror, what we do is we take and we start at the actual image, and then we're going to make the incident ray travel parallel to the principal axis, and then it will reflect back and go through the focal point. So that's for the very first ray. The second ray will actually travel again from the actual object. It will hit the mirror and then it will bounce back. And then we actually trace these rays over straight to the top of the image, and that is where these two intersect is where the image occurs. So again, here is another example. This one again was the real and inverted concave images in the concave mirror. And again, you start at the actual object, and we're going to take and draw the first ray parallel to the principal axis. It's going to hit the mirror and reflect back and go through the focal point. And then the second one will actually travel down at an angle, hit the mirror, and then go backwards. And then where those intersect, again, is where the image is. And so then we're going to do something similar for the convex mirror. And again, since these are on opposite sides of the mirror, we know that these are actually virtual and upright. And again, we always start at the object. We draw the ray parallel to the principal axis. It hits the mirror, and it's actually going to extend away from the focal point. And then again, we have this one coming down at an angle. It's going to hit the mirror and it's going to go back. And then we trace the rays through the mirror and it's going to hit through the focal point. And where these cross is actually where the image should be. So let's look at an actual example. So for that one image that we did the example for, we ended up with the object's distance was 1.0 centimeters from the mirror. The image distance was negative 0.8 centimeters from the mirror. The focal point was negative 4.0 centimeters from the mirror. This image was virtual and upright, so that meant that they are on opposite sides of the mirror, the image and the object. So when we draw this out, it looks like this. So again, this is the principal axis. We would actually measure with our ruler, and we would measure the object distance from the mirror, which was 1.0. We would measure the image distance from the mirror, which was 0.8. So that's how we got these distances. We would measure the focal point from the mirror, which was 4.0 centimeters. So that's how we got here. And then the other piece that I forgot to say was the magnification. So according to the magnification, the image itself is actually in relation to the actual object is 0.8 to 1. So that means it's going to be a little bit smaller than the actual object. And so that is actually, again, represented in our actual mirror diagram here, our ray diagram. So the only thing that we have left to do after we put in the object and its distance, the image and its distance, the focal point, and the magnification is now we need to draw our rays. So remember, whenever we draw our rays, we always start at the object. We're going to draw the first ray parallel to the object. And since these objects are on the opposite side of the mirror, it's going to hit the mirror and it's going to reflect back up. And then again, we have the second one that's going to go down at an angle, hit the mirror, and go back. And then we're going to trace these rays through the focal point, and where they actually intersect should be where the image is, and that's where we see. Okay? So that is it for the ray diagrams. Reach out to me if you still have questions on these. Thanks.